Good morning, Morgan. And good morning to any of Morgan's friends that are going to join us for this video today. And today we're going to learn about line numbers and I think how to copy beautiful soup objects and do some comparison to make sure they're exact copies. But anyway, with that, let us learn about line numbers. Okay, I don't know what they are. Let's figure it out together. Come on, machine.
The HTML.parser and HTML5 lib parsers can keep track of where in the original document each tag was found. You can access this information as tag.sourceLine, line number, and tag.sourcepos, position of the start tag within a line.
Alrighty, okay, so what is this source line? It says it's the line, this is where it is in the original document, and then the source position. All right, let's see if we can puzzle this out by looking at the example. All right, so we create our beautiful soup object. We've got two P tags in there. And let's see, what are we looking for? We're looking for the source line, the source position, and the tag string. Okay, so this string here, it says that the source line is 1. Okay, the source line, you have access to information. And let's see. So I guess that means it's the first tag, and then the next tag, the second one. But I don't get this, what the 0 means. It says the position of the start tag within a line. Start tag within a line. Okay, I don't know what that means, but I know it's 3. All right. Oh, wait a second. When we ran the program, it came back as 4. Huh. Well, if this is okay, 0, 1, 2, 3, 4. Is that how it works? This is the first instance, the second instance, and then this is like, so remember it starts off at 0, so 1, 2, 3, 4. Is that how it works? I guess it does until we find out that it doesn't. Let's keep going.
Note that the two parsers mean slightly different things by sourceLine and sourcepos. For HTML.parser, these numbers represent the position of the initial less than sign. For HTML5 lib, these numbers represent the position of the final greater than sign. Soup equals beautiful soup, markup, HTML5 lib.
Okay, so depending on which parser we're using, because this is the HTML parser, those were how the numbers returned. And now because we're using the HTML5 parser, apparently these numbers are going to be different somehow. All right, let's take a look. Okay, so this is 2 and 3. Okay, so is it because this is it's within the body tag? I don't know. And then what about this one? It says 1, 1, 2, 3, 4. Oh, but look here. When we ran it, it was different for us. 0, 1, 2, 3. I don't know. I don't get these numbers. Do they make any sense to you? No. Let's keep going. All right.
You can shut off this feature by passing store_line_numbers equals false into the beautiful soup.
Okay, so these numbers are so important that it gives you the ability to turn them off. Okay? All right, so now we're not going to keep track of the line numbers. All right? So what happens when we go to look for the source line in the tag? Nothing. Okay? Oh, look, the LXML doesn't support this. Okay, wonderful. All right, so let's continue.
Comparing objects for equality. Beautiful Soup says that two navigable string or tag objects are equal when they represent the same HTML or XML markup. In this example, the two B tags are treated as equal, even though they live in different parts of the object tree, because they both look like B pizza /B.
Markup gleich Pi want B.
Oh, geez, I don't know how I managed to switch it over to German. All right, so here's the beautiful soup object. Now we're going to look at the first and the second. Are they equal? Well, and the first one is going to be equal to pizza. And the second one is pizza. And guess what? They're true. Now, what is this? So now we're going to set... Oh, now we're asking it, is the first one and the second one the same? Okay. Oh, I'm sorry. This is me rewriting the thing. This is what I ran. Okay. Let's go on. So now it's the previous element and then of the first equal to the previous element of the second one. Well, let's see. The previous one said I was, and the other was and more. Where did that come from? Okay, prior to this, it was I want for this one. And then for this one, it was and more. Okay, so I guess that kind of worked out like we were expecting. And because they're not equal, we got a false. Okay, let's keep going.
If you want to see whether two variables refer to exactly the same object, use is.
Okay, so that's kind of neat. So they're equal, but we know they're different. Okay, so how can you realize they're different? This will do it. Okay, so that we know that even though it looks the same, it's actually two different plots in the tree, right? And here's our tree. Bink, bink. No, they're not the same. Okay. All right. Okay, now I guess you have the ability to just copy object. Let's see how
Copying
that
beautiful
happens.
soup objects. You can use copy.copy to create a copy of any tag or navigable string.
All right, well, we have to import the copy module into the code. We do that, and then we copy this over, and then we say, hey, Len, what's in this P? And it shows us. Now, what's interesting is I tried to make it look pretty like this by putting running it through the prettify function, but when I tried to do it here, it blew up. Isn't that interesting? Okay, all right, so now we have a copy.
The copy is considered equal to the original, since it represents the same markup as the original, but it's not the same object.
Okay, so what they're saying is like it says the same thing, but they're two different things. Okay, like twins. Okay, so yeah, they look alike, but no, there's two of them. Does that make sense? Okay, I hope it did, because it did to me.
The only real difference is that the copy is completely detached from the original beautiful soup object tree, just as if extract.
Oh, so there's a beautiful soup object tree. That's good to know. But look, just testing it, then we find out, oh man, this one's an orphan. Okay, so there you go. So that's for today's reading. Let's go ahead and stop here, and then we'll go look at the code and the output. All right. And here we are in the output. And usually I go like, hey, if you want this code, send me, say something in the comments. I'll get it to you in an email, or I'll give you an email address that you can send the request to. But the reason I wanted to show this to you is because something weird happened in the code, and it happened when we started copying objects. Here we go. So here we are. I'm making a copy. I'm taking the soup, and I just want to see the P flags, right? And I'm making a copy of it into P copy. Now I've got two beautiful soup objects. One of them is legitimate. It's the original. The second one is an orphan. P.copy is an orphan. And here's the thing. I take the copy, and I run it through the prettifier, and we get an output, right? But when I try to do it again here, why I wanted to do it twice, I don't know. But it's a good thing I did, because what happened was it freaking blew up on an error. Said that I couldn't use the prettify function on the object. So, but it's the same object. It's the orphan one. Okay, it would kind of make sense if the first one was in the beautiful soup tree and the other one wasn't. But this is kludgy. I don't know why this is happening, but I wanted to point that out to you, and maybe we'll figure it out together at a later date. All right, with that, let's go over and take a look at the output. And here we are in the output. Lots and lots of output. Oh, man, that prettifier does make it look pretty, doesn't it? Look, there's our all chakra blue left over from videos past. I know, I'm a bit of a pack rat. I never throw any code away. And for somehow, I don't know how, but I know exactly where every little bit is. So when I go to write code, I go like, I know where that code is. And that's why I don't ever delete any code, because I keep it laying around so I can steal from it later. All right, so that's it. That's it for today's video. Y'all go out and play nice today, and we'll see you in the next video. Later.